Hi, I'm Vanessa Urdaneta, a student in Dr. Scott's admin class MIS 4478, as part of the Team Texans. I will be providing an informative presentation about Moore's Law. Some of the topics that I will be covering are the author of Moore's Law, what is Moore's Law, some of the components affected by the law, and how the law affects us today and how it will in the future. Let's begin by introducing Gordon E. Moore. He was born in San Francisco, California on January 3rd, 1929. He is the co-founder and chairman emeritus of Intel Corporation. He's also the author of Moore's Law. Now let's explain Moore's Law. As quoted here in his famous paper of 1965, published in Electronic Magazine, Dr. Moore explains that the number of transistors on a chip will double approximately every 2 years. For nowadays, they actually say it'll double in 18 months. Let's go ahead and now explain and show the Morse curve. You can see in the picture that the number of transistors being shown on the right are almost doubling as the time increases, and it also explains how we have accomplished this and how Intel shows it. But to better understand what the law does and means, we must first understand what a transistor and a CPU do. So let's move on to what is a transistor. A transistor is a semiconductor of energy current. One important fact about transistors is that with electricity, transistors can both switch or amplify electronic signal, letting you control current moving through a circuit board with precision. Let's move on to what is a CPU, or a processor. It is the central processing unit. What does it do, you're probably wondering? It decodes information and executes the correct computer program. It is pretty much the brain of a computer. Now let's discuss, now that we understand Moore's Law, let's discuss why it is important or relevant in the technological world. There are a few reasons. One is that Moore's Law and big companies such as Intel, they're able to go ahead and make new chips that are increased in performance while they're lowering the cost, so they're more accessible to people. It is also said that with Moore's Law, you're able to predict what competitors will be working with in the next 18 months. So it kind of gives you a heads up of what's coming up next. Now let's move on onto the future of the law. Some people say that the future of the law is close to an end, but it is very hard to calculate an exact date when will it be reached, because we can reach a technical barrier as well as economic barrier. By a technical barrier, I mean that architects will reach a point where transistors cannot be made any smaller. Even though they're doubling in size, we still want to keep the compact size. Right now, we're at a molecular level, and we're about to reach an atom level, meaning that they're very, very small. The future of the law, it's leading to the point that in 18 months, actually the time is going to minimize, maybe to a year, maybe to even less than that. As we see the future coming to us, we see that technology is increasing and the cost of it is being lowered, making it very accessible to people. So to summarize Gordon's Moore's law, it states that the number of transistors on a chip will double approximately every 2 years. Nowadays it would be 18 months. This has helped technology increase its performance but also making it accessible to everyone by lowering the cost of the computers. Now that we know what is included in a Moore's law, transistors, they show the current and help you guide through the current. A processor is the brain of the computer. Why is this important again? This is important because it's leading us to the future of fast technology with better performance and cheaper price. Now, where is it taking us? It's taking us to a world where everything's going to be exchanging a lot faster than it did before. One thing to keep in mind is that as technology grows, we could reach the point of singularity. Singularity means the advance could exceed that of a human being. With this said, we should always keep in mind, what are we making computers capable of? But thank you very much for listening to the presentation, and on the following slide I would like to give credit to all the resources I was able to use to complete this presentation. Thank you and have a